In this video, we're doing improper integrals with infinity in the bottom bound. So let's start by rewriting as a limit L approaches negative infinity. Temporarily change the bottom bound to L reminding us to take the limit 1 over 2x minus 5 dx. This is a simple u sub, so if u is 2x minus 5, du is 2 dx. We don't have a 2 dx, so if we put a 2 on the inside, we're going to have a 1/2 on the outside. So now we have 1/2 integral 1 over u du, which is natural log. So we have 1/2 natural log, absolute value. Very important to put the absolute value here of 2x minus 5. So now we have 1/2 natural log 2x minus 5 from L to 0, and we're going to take the limit as L approaches negative infinity. So if I plug in, I get 1/2 natural log absolute value of negative 5. Notice when I plug in the 0 here, I get a negative 5, minus the natural log absolute value of, this time, negative infinity. Well, so I don't care what the front is, because if we notice the back, when we subtract the natural log of infinity, we get negative infinity, so this diverges. They won't always diverge, but several of them do. Let's take a look at example 2. So in example 2, again, we're going to rewrite this as a limit. L approaches negative infinity. We are integrating from L to negative 1, 1 over root 2 minus x dx. Again, this is a simple u sub, so u is 2 minus x, du is negative dx. We don't have a negative dx, so if we want to put a negative on the inside, we're going to put a negative on the outside. So we have negative integral 1 over root u du. Now this is one we almost have memorized. If we were to divide by 2 on the inside and multiply by 2 on the outside, we would get negative 2 root 2 minus x. So now we've got the limit as L is approaching negative infinity of negative 2 root 2 minus x from L to negative 1. Let's go ahead and plug in, so we get negative 2 root 2 minus negative 1 minus negative 2 root 2 minus negative infinity. Well, so again, the front is not going to play much of a role here. We've got a double negative is a positive, so this becomes positive infinity. And again, this one diverges. They won't all diverge, but many of them do. In example 3, again, let's start by rewriting this as a limit as L approaches negative infinity. We are integrating from L to negative 1 of e to the negative 2x dx. Once again, we have a u sub. U is negative 2x. du is negative 2 dx. So if we want to multiply by a negative 2 on the inside, we have to multiply a negative 1/2 on the outside. So we have negative 1/2 integral e to the u du. So that's negative 1/2 e to the negative 2x. So now we're going to take the limit as L approaches negative infinity. We've got negative 1/2 e to the negative 2x from L to negative 1. That gives us negative 1/2 e. We have a double negative makes a positive, so we have e squared minus negative 1/2 e. Now this time, when we plug in our L and we throw in our negative infinity, we're going to get positive infinity. So once again, in the front, we're not really caring, because in the back we have a positive infinity. And again, this diverges.